Right, this is question 9 of the mock paper that you recently did, and what I'm going to try and do in this video today is show you a couple of ideas and a bit of examination technique which will help you link in or think about the mechanism that you need to use. Now, the first thing that I would do is go and highlight areas of things which might link in with something I know already. Okay, 2-bromopentane, we know that that is a haloalkane. Okay, most mechanisms with haloalkanes we can think about there. Okay, and it's also reacting with ethanolic potassium hydroxide. Now, that should jog your memory. Whenever we've got an ethanolic reagent or ethanolic potassium hydroxide, that would indicate that the hydroxide ion is acting as a base, therefore it's going to remove a proton. Okay, and this mechanism will be a elimination. It also indicates that two structurally isomeric alkenes are formed. Okay, so two structurally isomeric alkenes are formed, and the structurally isomeric would mean something like the E and Z forms of isomers. Now, the actual question is very, very specific over here. It's indicating to you, first of all, to name the mechanism. So I've already told you that that's elimination, and you should be able to recognize when elimination occurs. And outline. Whenever you've got this word outline the mechanism, that means that you need to draw it out. At this stage, what I would like you to do is take a couple of minutes for yourself and try and work through the mechanism and drawing out the mechanism yourself. You might want to pause the video over here whilst you're working out, and then I will give you the answer to this. Right, the way I would actually tackle this is by drawing out the molecule in question, drawing out the displayed formula of the molecule in question, and that might jog your memory in terms of looking at this bromine, carbon-bromine bond over here. I'm just going to highlight the bromine and the carbon there, for instance, and that should indicate, or we should have an idea that that bond there is polar. That is because bromine is greater or has greater electronegativity than carbon, so we could indicate that that is slightly negative or delta negative, and that carbon there is delta positive. Now, the question actually also tells us about ethanolic potassium hydroxide. We know potassium hydroxide as KOH. However, potassium hydroxide is ionic, and it's going to be K plus OH minus. You will need to refer back to your notes for the reason why. Okay, I'm just going to use the OH minus over here. If you put the potassium hydroxide as the covalent potassium hydroxide, you're going to be losing marks. But let's just move this across over here. Okay, that's potassium hydroxide there. Now, we need to show how the potassium hydroxide, which is acting as a base, reacts with the bromo or 2-bromopentane in order to form the alkene here. Now, a base is a proton acceptor, and a proton being a H plus ion, an ion which has lost its electron. Now, if we look at what the question is actually telling us over here, the question is actually telling us that the double bond is forming between the second and third carbon in this instance over here. So we need to form our double bond between the second and third carbon. We can react this hydroxide group in two ways or two places. In instance, in theory, we could react our hydroxide with this hydrogen over here. However, that's not going to form the double bond where we would like it. The alternative is to react the hydrogen with, or the hydroxide group with this hydrogen over here, which will form the double bond that we would like, and we would indicate the mechanism by drawing our full-headed arrows. Okay, so that's indicating that that hydroxide group is reacting with the hydrogen. It's actually taken the hydrogen or the proton away, leaving this area over here with an electron from the hydrogen and the carbon electron there again. Now, considering this area, or these electrons need to go somewhere, we're going to indicate and show that they are taking or making a double bond, because carbon can form double bonds with itself.